Okay, so today we already start a little bit about the lesson number 36. Okay, so we continue with this page number 7. Okay, today we talk about the interference. So we will have two types of interference. Okay, it's constructive or destructive interference. Okay, so I will repeat a little bit about the path difference. So this part actually is a bit like confusing, but we're trying our best to understand about this. Okay, path different is actually the distance traveled between the two waves. So we compare what is their extra distance travel. So for example, first case, constructive interference. Okay, how I know at the end when the interference they will get a constructive interference? How? So we need to find comparing these two. Okay, so for the source 2 actually is starting extra one wavelength. Okay, this is called one complete wavelength. This is one complete wavelength. So we found out that as source 2 and source 1, actually source 2, they travel extra distance with one wavelength. When one wavelength and starting at here, they are emitting the wave actually in phase. Okay, in phase means that when I'm at crest, you also at crest. So we say this is in phase. Okay, so when somewhere at here, if let's say they superpose interference, okay, superpose at these two position, you will find out that crest meet with crest. So when crest meet with crest, it will get constructive interference. Okay, so when one complete wave or multiply of the complete wave, we will actually producing a constructive interference. How about destructive interference? Okay, we will found trying to find out what is their path difference, extra distance travel. Okay, extra distance travel by the source too. So at here, can you see that this one? Let me highlight. This one, use blue color. If one complete wave is here, okay, if one complete wave is this, is one complete wave, but here extra travel how many? Actually, is only travel extra half only. This one actually is half wavelength. If half wavelength, starting actually they are in phase. I emitting crest, you're also emitting crest together, go out. Okay, but because of the path difference is half wavelength, at the end you'll find out that the point that we intercept, this is trough. Okay, another wave is crest. Crest meet with trough. So crest meet with trough. At the end, we get a zero amplitude. Okay, this is called destructive interference. So this is the idea. Okay, then we having an example. This is theory. We using example helping us to understand. Okay, so this one is two source. Okay, the source will emitting out the wave. So this is blue color is actually from the source 2. Purple color is from the source 1. So when the source 2 here, they come out with the wave. Okay, then source 1, they also emitting with the wave. They superpose or they meet up at P2, point 2, P2. So at here, they were producing constructive or destructive. How we know? Okay, so we look at this example. This is one complete wavelength. 1, 2, 3, 4, 5, and 6. Okay, the wave that emitting out by the source 2, actually I got 6 complete wavelength. Okay, then how about the source 1? So at here, 1, 2, 3, 4, 5, 6, 7. I got 7 complete wavelength. So boys and girls, you look at here. You look at the blue color here and the purple color here. Can you see that when they meet up or when they superpose, okay? When they superpose, actually it's trough meet with trough. So what type of interference we were producing? We were producing constructive interference. So if you find out their path different, okay, what is their path different? You minus extra distance travel, we minus. Okay, so 7 complete wavelength minus 6 complete wavelength, I know that I get extra travel a wavelength, a complete wavelength. So I will get a constructive interference. Okay, so at here one complete wavelength, if extra travel one complete wavelength, or n times complete wavelength, okay? Two complete wavelength, three complete wavelength, doesn't matter. At the end, no matter at any point, actually when they superpose, they were producing constructive interference. So you look at here, when they meet up at here, can you see this is a trough, meet up with trough. So at the end, they will producing constructive interference, okay? How about destructive? How destructive interference is producing? Okay, we look at this case. The wave due to the source 2, we count goes to point 1. 1, 2, 3, 4, 5, 6. 6.5. Dear, 6.5, not yet one complete wave. 6.5 wavelength. Okay, then S1 purple color. 1, 2, 3, 4, 5, 6. Okay, what is their path difference? 6.5 minus 6. So S2 travel extra half wavelength. Travel extra half wavelength. When they travel extra half wavelength, can you see? This is a crest. Meet up with a trough. So at the end, destructive interference is producing. Okay, so using the formula here, theoretically here, okay, if n wavelength can be 1 wavelength, 2 wavelengths, 3 wavelength, 4 wavelength, n wavelength, it will be a constructive interference. Okay, from the path difference, we can determine. So at here, this sentence say that path difference can be determined whether constructive or destructive interference can be produced. Okay, so if you calculate their path difference, you found out that it might be 0.5 wavelength, 1.5 wavelength, 2.5 wavelength, got half one. That means that they were producing destructive interference. Okay, until here, any of you got any question there? If no question, there is a button, you can you can press the reaction button to let me know that we can proceed. Okay, Okay, then we go to the next page at here. Okay, here we enlarge the wave. So this one, S1 is 1 complete wavelength. S2 is 1, 2. 2 wavelength minus 1 wavelength. So you will get 1 wavelength, n wavelength. This is a whole number. So I know that these two waves, when they superpose, they will producing constructive interference. Okay, then this one S1.5. So this is 1.5 wavelength. 1, 2, 3. Okay, 3 wavelength minus 1.5, I get 1.5. So I understand, even I didn't have this diagram. Okay, from the path wave difference, I can know actually when they superpose, they are producing destructive interference. Can you see? Crest meet with trough. Okay, this is a common case when the source is actually in phase. Here, look at here, this one, in phase. What does it mean in phase? Okay, just now I told you, I come out with crest, you also crest. We are go out with the same phase, go out. So our phase difference actually is 0 degree, okay? Then now I'm going to tell you, in your exam, they might be come out with the source, okay? They are out of phase. They are not in phase. So when they are crest come out, another source is from the trough come out. So can you see that this case is opposite case? So I count with crest, here come out with trough. This one is they are out of phase. Just now is in phase. Right now is the source they come out actually is a 180 degree phase difference. So when you want to solve the partial question, you have to first find out this question actually the wave come out in phase or not in phase. This is the first thing, okay? So if let's say they are out of phase, so you look at this diagram, this is 1 complete wavelength. Okay, the green color is 1, 2, 2.5. 2.5 minus 1, you get 1.5 wavelength. So from the diagram, you will saw that this is trough and trough. Actually, they become constructive interference. But right now, is not a whole number. It will be changed opposite way with just now the in phase. So right now at here, if they are source actually starting is already out of phase, so our theory need to reverse. Okay, so just now is 0 0.5, 1.5, 2.5, that one is destructive. When it comes to this case, when the source is actually out of phase, everything in opposite way. Okay, when you saw the 1.5, okay, 2.5, 3.5, or 0.5, they were producing constructive interference. And so on for the next one. If they get a whole number, this is destructive. So at here, this is the summary that I trying to make you understand. Okay. In phase is starting what we're talking. If in phase, their path different is a whole number wavelength, then that is a constructive. If in phase is got 0 0.5 to 1.5, 2.5, got 0.51, that one will be producing destructive interference. Now we add on one more case. If let's say at starting the source, they're already out of phase. So if they get a whole number, actually they are producing destructive. If they get 0.5 wavelength, they get a constructive. So the idea, the theory have to opposite way. Okay, until here, any question? We are going to try our past year question. We're using our knowledge trying to solve the past year question. Okay, Prasan, okay. Fatima, okay. We're using the past year question, trying to understand more. Okay, we do the past year question. So it goes to the next page. Wave generator at point X and Y producing the wave. Okay, so at here they're producing the wave. Okay, something like this. Wait, something like this, they're producing the wave. So here producing the wave. At point Z, the wave from X have same amplitude as the wave from Y. Okay, and distance X, Y, X, Z, and Y, Z are shown. Okay, here, dear. Let me have a look. Okay, here. That is the thing that I told you. We need to determine at starting, are they in phase? So at here, when the wave generator operate in phase. So this is the first point we need to find out. In phase or out of phase. Okay, so this is the first. Okay, next. Amplitude of oscillation at Z is 0. When they coming at here, so there is a wave, something like this come here. Okay, another wave, something like this come here. When they meet up at the Z at here, amplitude becomes 0. So second thing we can determine is this is a destructive interference. Okay, amplitude becomes 0. So it might be a crest meet up with a trough. So at the end, they get 0. Okay, they told you same amplitude, so they can cancel out and become 0. Okay, here they're asking you, what could be the wavelength? So at here, path difference. Because this is destructive, so it must be a n plus half wavelength. It must be. So this one, it must be this. Destructive in phase, so it need to follow this. Okay, so at here, path different. What is a path different? 34 minus 24. This is their path different. Extra distance travel. Okay, just now I saw the answer. Some of you already answered. Yes, correct. Your answer is good. Okay, here. So n plus half wavelength. So this one you will get 10 equals to n plus half wavelength. Okay, what wavelength actually is makes sense. So you can try when n equals to 0, what is your wavelength? N equals to 1, what is your wavelength? N equals to 2, what is your wavelength? So check what is the possible wavelength. Jore, correct. Like others, can you try? I already give you the idea, so can you try? Fawal, correct. Good job. Try to find out when n is 0, what is the wavelength? N equals to 1, what is the wavelength? N equals to 2, what is the wavelength? From there, you can try to get A, B, C, D. Which one is, it might be the wavelength. Okay, let me have a look. Prasan, correct. Kai Chen, correct. Okay, dear, easy, right? You just do substitution. Okay, so at here, the answer that I get for the one is 6.67 cm. Then this one is I get 4.0 cm. If n equals to 3, I get 2.9 cm. So at the end, actually, I know that answer C is the possible wavelength. Okay, answer C will be the possible wavelength. So, dear, you get the idea or not? First step, you determine the wave generator actually come out with the wave actually starting in phase or out of phase. Then second thing, determine is constructive or destructive interference. Then third things, what formula you use? Half or actually whole number wavelength. Okay? So, if no question, we go to question number 2. Is it okay? Okay. Okay, next. Two loudspeakers. So we got two loudspeakers emitting the sound wave that are in phase. So they're here. First step, we know in phase. Okay, and the wavelength, they give wavelength. An observer O is able to stand anyway on a straight line that pass through X and Y as shown. The observer stand at point where the sound wave from X and Y meet in phase. Okay, they will meet in phase. So second thing, when they meet in phase, that means crest meet with crest, trough meet with trough. That is meanings of in phase. So we will form constructive interference. Okay, second step. Third step. Okay, path difference for constructive interference. It will be a whole number of wavelength. Whole number of wavelength. So at here, it will be n wavelength is 0.75. Okay, path difference. What is their difference? Okay, this is from here until here. Okay, this one is OY. Okay, this is the distance of the wave OX. What is the extra distance travel? Path difference, that means extra distance travel. So we should using OY minus OX. So what is OY minus OX? So can you see that OY, XY? So actually the difference is here. The different path difference, extra travel distance is here, which is XY. Okay, XY equals to N 0.75. So at here, you have to find out what is your distance xy. How we find out? You using this value, you do substitution inside here, you find out the n value. So you need to find n. Find out the n for A, B, C, D. Then ask yourself which one is the correct n in order to producing the constructive interference. So constructive interference, this n must be a whole number. Cannot be 0.5, whole number. So right now, what you need to do is you using the ABCD distance XY, do substitution and find out which answer they will able to give you a whole number. Prasan, no? Prasan, try again. Wesley, correct. Okay, why it is a constructive, Wesley? It's because they say that observers standing somewhere at a point that the sound from X and Y meet in phase. Meet in phase, that means that these two waves, they are crest meet with crest. Trough meet with trough. This is meanings of in phase. So if crest meet with crest, this is constructive. Can or not, Wesley? Washini, correct. Fawal, no. Jore, correct. Fatima, correct. But then last question also in phase, but it's destructive. Okay, dear, here. Because last question, oh dear, they got two. Okay, Wesley is here. Look at me. First step, we determine is in phase or out of phase. So from here, if we know in phase, then we know that which formula we are going to use. Okay, either it's whole number wavelength or half number of wavelength. Okay, then after that, you look at here. When they meet up at Z point, amplitude is 0. Meet up at point Z, amplitude becomes 0. So I know that this, when they meet up, they're producing destructive interference. From this sentence, I know destructive. For the next question here, in phase. So I know that I also need to apply either one. Okay, these two either one. Okay, then after that, how I know it's constructive is because of this sentence. Okay, X and Y, they meet in phase. Not this part. This part is talking about starting the wave come out in phase. This part is talking about when they meet up, they are in phase. So this is constructive. So Wesley, is it okay? Manjo, correct. Okay, good job. Fawal, no? Fawal? Does in phase refer to the wave with two crests or the wave starting? Okay, dear. Fatima, look at here. This sentence meaning that emit the wave out. So this one is talking about starting when they come out is in phase. So this one is helping us to determine we are going to using this formula or we are going to using out of phase formula. Okay, so for the first one, first sentence here, they emit the wave in phase. It's helping us to determine which formula we use. Then I want to know at the end is constructive or destructive. It's because of this sentence saying that meet in phase. They meet up. This one is emit. Emit is starting. Meet up is ending. Fatima, do you get my idea? Fawal, correct. Now you get the idea. Okay. So you see, wave generator is emit, starting, come out in phase. Then this one is output, ending, result is destructive. Okay, dear, here. So if you do it if you do calculation correctly, you will get, for me, I get 4.67. Then this one 3.67, 2.67, and this one is 2. So my answer will be donkey. Because this is constructive, it must be a whole number. Come back to here. Constructive interference when they emitting, source emitting in phase. So when they are whole number of wavelength, this will be a constructive interference. Okay, question number 2, is that clear? Can I proceed to the next question? Page number 10, dear. Let's go. Okay, here. Two sources of microwave P and Q produce coherent wave with a phase difference, right, dear? Highlight. Phase difference 180 degree is out of phase. It's out of phase. How did you, when Prasan asking, how did you get the minus? How to find the n? How did I get the minus? Which one minus? OY minus OX. Oh, okay. This is this part. This path actually is the path different. What I highlight blue color, this is the path different. OY travel extra distance compared to OX. So OY minus OX, this is the extra distance travel by the OY. So OY minus OX, this is XY. XY. Prasan, is it okay? This one, X to Y, actually is path different, extra distance travel by OY. Okay, like there, next. Like there, phase difference of 180 degree. So at here, this one is the first thing I know that I need to use this part. I need to use this for either one formula, okay? So at here, at the point S, that means that meet up, this one is meet up. At the point S, there is a minimum interference. So ask yourself, what kinds of interference you get? Destructive. Second, I determine. This one is I determine the source. So now I determine the output. Output is destructive interference. Okay, destructive interference for the 180 degree difference. Actually, the path difference, it should be a whole number. It will be opposite with just now. So we come back to here. Look at this. If out of phase, okay, I want to get a destructive interference. Actually, it's a whole number. Or here, this diagram, out of phase, I want to get a destructive interference. Actually, is whole number of wavelength. Okay, so here, this one, okay, here. Distance QS minus PS. That means that QS is longer distance. Okay, It will be what? It will be a path different. Okay, which one could be represent your path different? A, B, C, D, easy. Correct, Fawal. Answer will be C. It will be a whole number. It will be a whole number. Is it okay, dear? Vashini, correct. So first step, you determine the source. Source is in phase or out of phase. Second, you determine this is a constructive or destructive output when they meet up. So they got two parts. Okay. Then this one is destructive interference, and they are starting their wave is actually out of phase. So their path difference should be equals to the whole number of wavelengths. So actually the idea is here, out of phase. Destructive interference, so it will be a whole number. Actually, it's opposite with just now what we learned in phase. Okay. So until here, is it okay? Can we proceed to the next question? Okay, Wesley, okay. Others okay, Fawa okay, Fatima okay. Okay, good job. Okay, the diagram shows that two source of wave S1 and S2. They oscillate, source oscillate with a phase difference. Like highlight. Source, here, this is our first step. So I understand they are out of phase first. Okay, out of phase. The source each generate a wave of wavelength 2. Oh, okay, this is the wavelength. Okay, wavelength is 2 cm. Each source produce a wave that has an amplitude XO when it reach to the point P. Okay, they want to know the amplitude of point P. When they meet up at point P, what is their amplitude? Okay, how we solve this question? Half different is equals to n wavelength. We want to know this one n is a positive or negative, whole number or not whole number lah. Okay, so we just put a n first. Okay, path difference is extra distance travel. So at here, 30 minus 5 is the extra distance travel by the S2. Okay, equals to unknown n. Wavelength is 2 cm. I didn't change to meter is because here I also using cm. Okay, here when I do calculation, I will get 4. Okay, can you tell me if n equals to 4, actually I will get a constructive or destructive interference? Any of you can tell me? Type your answer to the Newton scholar here. It will producing a constructive or destructive. Fawal correct. Washini correct. Jore correct. Wesley correct. Oh, good job. Prasan correct. Yeah, be confident dear. Manjo correct. Fawa correct. Kai-chen correct. Oh, everybody know. Okay, destructive. Yes, dear. This one will producing a destructive interference. It's because it's a whole number. It's not 4.5, 2.5, 3.5. It's a whole number. Whole number for the out of phase, it will be a destructive interference. Destructive interference means that crest meet up with a trough. So what is your amplitude? 0. 0. But why, Wesley asking, but why use the whole number formula, not the other? Okay, Wesley, you look at here. First, we already tell you that the source that oscillate out of phase. They out of phase. Okay, out of phase. Then after that, we look at this example. We look at this example. This is one complete wavelength, 1.5. 1.5 wavelength. Okay. Green color is 1, 2, 2.5. 2.5 minus 1.5, you get a whole number. Look at this diagram. I come out with crest. You come out with trough. We are out of phase, 180 degree out of phase. When we meet up at point P at here, can you see that? Crest meet with trough. I will transmit with trough, I will get a destructive interference. So for out of phase, when they get a whole path difference, get a whole number of wavelength, actually they're producing destructive. They're producing destructive. So when we're answering this kind of question, first question asking yourself, the source come out in phase or out of phase? Because they will totally giving you different answer. Okay. Then after that, second thing, ask yourself, is constructive or destructive? If constructive, it should be whole number or actually half of the whole number. Wesley, is it okay? So is it also because of the phase difference is a whole number? Phase difference 180 degree is path different. Okay. Path difference is a whole number. No, this is not whole number. What? 2.5 minus 1.5. Yeah. You means path different. Yes. Path different and wavelength. It is a destructive interference. But just now at here, you see, if whole number for the in phase, we're producing constructive. If out of phase, whole number is destructive. They are opposite way. Okay, like there we goes to your last page number 11. Okay, EM wave of wavelength 0. Okay, this one, they give you the wavelength. So we mark it down. Later on, when you want to do, you can straightly get the idea. Wavelength is here. I emitted in phase. You see, emitted. This is what I want. Emitted. So this is the first point we need to find. In phase. So starting, they are in phase. Second thing, if in phase, constructive is constructive. Okay, the path difference, I write like this, path difference. Cannot let on you thought is potential difference. Okay, path difference is actually a whole number wavelength. If destructive, path difference, it should be a m plus half wavelength. So second things, you have to be very clear the formula that we are going to use. Okay, here a detector move along a path that is parallel to the XY. A pattern of intensity maximum and minimum is detected. Distance xz is 1.3. Distance xyz is 1.2. Show that the path difference, at point Z between the wave from X and Y is 3.5. Okay, they want you to prove that their path difference actually is 3.5 wavelength. Okay, how you do that? Path difference actually is using the longer distance, 1.38 minus 1.24. Easy, right? Path difference, extra distance. So at here, I get 0.14. This one is meter, but this one is not in terms of wavelength. How we are going to find in terms of wavelength? Okay, one complete wavelength actually is 0.04 meter. I got 0.14 meter actually is how many wavelength? Mathematics, how you solve and in terms of wavelength. So we just using 0.14 divided by 0.04. So at the end, for me, I get 3.5 wavelength. Is it okay? Fatima, okay. How about others? Path different, find their different. In terms of wavelength, so we divide with the wavelength. So I know that actually is travel extra 3.5 wavelength. Okay, here. Phase different. Oh, don't mix with the phase and path different. Phase different, we already learned in previous chapter. Okay, phase different. I recall back. Phase different actually is the distance between the two wave. Okay, extra distance between the two wave actually is path different. Path difference divided by wavelength times 360 degree. We learned this before that. Extra distance traveled by the wave or distance between the two wave divided by wavelength times 360 degree. So at here, we got extra travel 3.5 wavelength. divided by 1 complete wavelength times 360 degree. Okay, this is the way how we calculate phase difference. When you when you read the question, solve the question, do not confuse between path and phase. Phase can be in terms of degree or in terms of pi. Path is distance different. Okay, so when we apply this formula, this one path different actually is in terms of wavelength. In terms of wavelength. So I got extra travel 3.5 wavelength compared to another wave. Okay, so that means that the xz at here, xz is travel extra 3.5 wavelength divided by wavelength times 360. So at here, our answer will be 1260 degree. What is the path difference? It's 1260 degree. Okay, this one we learned it before that. Now we using the idea that we learn about path difference, then we combine with phase difference. Okay, last time when we learn about phase difference, we find out the distance between the two waves. Okay, one lagging, one leading. Okay, we find the distance between them divided by wavelength times 360 degree. Okay, any question until here? Any question? Can Kai Chen okay, Wesley okay, Washini okay, waiting okay, okay, good job. Okay, the wave from X alone having same amplitude as Z as the wave from Y alone. Okay, so the wave come like this. Wave come like this. Now the question asking you at point Z, when they meet up, state the intensity at point Z. Okay, intensity can be related with amplitude. Okay, intensity is directly proportional to amplitude square. So before you answer intensity, ask yourself, what is your amplitude when you meet up at point Z? So how I know, teacher? Then you have to determine at point Z actually is constructive or destructive. So any of you can tell me construct or destruct when they meet up at point Z. First step, they are in phase. Second step, they are construct or destruct. From their path different, they are construct or destruct. Wesley correct. Let me check. Fawal correct. How about others? Do you get the idea? First thing, they are in phase. Second things, we understand construct must be whole number, destruct must be 0.5. Now, based on the path difference we calculate at here, it should be a construct or destruct. Kai Chen correct, Fatima correct, Jore correct, Washini correct. Okay, deal. If destructive, okay, because of path difference is 3.5 wavelength, 3.5. So I understand when they meet up actually is destructive. So can you tell me destructive interference? When destructive interference, that means 1 plus like this equals to 0 amplitude what? Amplitude 0, intensity should be 0 also. Amplitude 0, of course there is no intensity. Is that clear there? Here, same amplitude. That's why they can get exactly 0 amplitude. They can cancel out. Okay? Any question? No question? Then we are going to the next lesson. Okay? So we goes to the next question. Next worksheet 37. Okay, young double slit experiment. Let me have a look. Young double slit. Okay, this one is young double slit. If you are graduate from SPM, this is not a new topic for you, okay? But if you are graduate from IGCSE, we didn't learn about this before that, okay? So, young double slit experiment is to show you about the interference, okay? When the wave coming and pass through the two gap, so each of the gap they will happening the diffraction, okay? Diffraction. Then the two waves they will superpose, okay? They superpose. When they superpose until the screen at here, they will showing you. They will showing you the pattern. Okay, so today what we learn, we need to using some formula, do some calculation. Okay, we can calculate the wavelength, calculate other thing also lah. Okay, here you look at here. Okay, the pattern, maybe we can come back here first, later I show you. Okay, so this one is the pattern that show on the screen just now. Okay, so when the light or wave coming here, so they will producing the wave. Okay, wave. So the two wave, they will interference at somewhere here and producing constructive, destructive, constructive, destructive. Like just now what we know lah. Okay, constructive, destructive. If they are constructive, they will producing bright fringe. Okay, if they are destructive, they will producing dark fringe. Okay, so at here, we having a formula, important formula. Okay, wavelength equals to AX divided by D. What is A, what is X, what is D? Okay, this one wavelength easy. From the diagram, we cannot see the wavelength, we cannot. Okay, but others here, when the distance between the two slit, okay, distance between these two source, this is called A. Okay, we label as A, symbol as A. Okay, the distance from the source until the screen, okay, until the point that we observe, this one is called D. Okay, this one D is the distance between the slit and the screen. So this is called D. And then one is called X. What is X? So you look at here, we were producing a bright fringes, dark fringes, bright fringes, dark fringes. Okay, so from bright to bright, adjacent bright fringe, okay, this is called X. This is called X. Maybe you say, teacher, I don't like bright. Can I choose dark to dark? Yes, sure. This one is your X, no problem, okay? So at here, we were having this formula to do some calculation, okay, for the young double slit experiment. Okay, here, we can come back to here. Okay, so you look at here. Okay, we look at the distance between two slits. So you look at the small black color part. Can you see? This is the distance between the two source, okay, the two slit. So when I'm increasing the A, here is writing D lah, but in our experiment, in our formula actually is A. Okay, I increasing my A. So what happened to my X? I decreasing. This one is decreasing. So you observe the screen. Okay, from bright to bright, that is your X. So I increasing my A, distance between the two slit. Can you see that my X actually will become smaller, closer? Okay, so this is one of the factor. Then screen L, slit to screen, in our formula actually is D lah. So have a look, starting at here. Then I increasing my distance from the screen. I found out that my X actually is increasing, right? Okay, so for this one, A here, in this simulation, it say A lah. But in our formula, we doesn't have this. We doesn't involve with slits width. It's because it doesn't affecting our X. It doesn't affecting our X, but it affecting what? It affecting the brightness. It affecting the brightness. Okay, so this one is dimmer. Okay, then after that, I increasing my width of my slit, the hole, I increasing. I found out that it become brighter. It's because more light can be passed through. More light can be passed through. Okay. Then wavelength. How about wavelength? Okay, wavelength. Wavelength increase, decrease is also affecting your X. Also affecting. Okay, then we come back to our worksheet here. We go to your page number 2. We look at the factor affecting the X. Most of the time, they like to asking you, what happened to your X? Because X is what we observe on the screen. Okay, so here, I will write down like this. Wavelength equals to X divided by D. So your X actually is wavelength D over A. I just rearrange. I want to find their relationship. Okay, the slit separation, the distance between the two slits. If I increasing the A, here I increasing my A, what happened to my X? My X will decrease because they are inversely proportional. They are inversely proportional. So you imagine a number divided by a big number, of course, you will get a small number at the end. So can you see that this one is larger slit? Okay, your A increase. So at the end, your X can be bright to bright. This one is your X. Okay, this one X bright to bright. This one is your X. Can you see that when your A increase, actually your X decrease? Will it affecting the brightness? No, but affecting the pattern of the fringe. Okay. Then we look at this. Just now the second one from the simulation got showing you lah, okay? But that it doesn't involve you in the formula at here is because it doesn't have any changes on the X. So look at here, their A is actually still the same. They didn't change the A, but they make the width at here, the gap, make the width at here become bigger. Okay, make it become bigger. When it bigger, it doesn't affecting our distance between the bright to bright fringe, okay? But it affecting the brightness. It will be allow increasing the brightness is because more light can be passed through from the bigger gap. Okay? So next, distance between the slit and the screen. Okay, so I rearrange again. X equals to wavelength D over A. Okay, my D increase. What happened to my X? My X also increase. They are directly proportional. Okay. Then after that, brightness will change, decrease. You imagine the screen getting further away. So your light actually spreading out over a larger area. So the brightness actually will be reducing. Okay. Next, wavelength. Okay, wavelength at here, most of the time they won't tell you what is the wavelength for blue color, red color. They assume you already know because in the previous chapter we learned about EM wave. We already know that their range for the visible light is 400 nanometer to 700 nanometer. We already know. They assume we already know. They won't tell you, they won't tell you. And then another one more thing, what is that? Okay, you have to know that actually red color wavelength actually is longer. Still remember the technique that I teach you or not? Recall back. Okay, here, if I increase my wavelength, so I make it become red color. Wavelength for red color is actually longer lah. Okay, so again, using the X equals to wavelength D over A. So if my wavelength increase, my X distance between the fringe actually also increase. Can you see that? Bright to bright fringes, X actually is increases. So this one, from here to here, X actually is shorter. So wavelength increase, X increase. Okay? How about the brightness? Okay, brightness will decrease. Why? Longer wavelength, actually more diffraction effect. Okay, longer wavelength, diffraction effect is more longer. This one, last lesson we're talking about this. Okay, when they increase the diffraction, that means that spread out more to more area. Okay, diffraction is spreading out of the wave. So you more spreading out, then of course your brightness will be decreased. Okay, here the last one I need to make some correction. This one is wrong. Okay, make some correction. So this one cancel out. Intensity. In the formula, it doesn't involve with intensity. So it won't affecting your fringe. Okay, the distance between the fringe, that means the X, it won't change. Okay, this one intensity, as I told you, is directly proportional to A squared. Okay, then after that, at here, if bright fringes is because of what? Construct what, right? Bright fringes is because of the constructive interference. Bright fringe is because of constructive. So if you get a bigger, okay, intensity higher, that means that your amplitude also bigger. You get a bigger plus bigger, then you get a bigger one. So that means that at here, what I want to tell you is the bright fringe are brighter. It will become brighter. Okay, because your A already getting bigger, A getting bigger. When they construct, we get a more greater A. So the intensity will causing the amplitude become higher. Our constructive interference, the bright fringes will become brighter. Okay, no change for the dark, no change to dark fringe. So intensity, the brightness, overall the brightness actually is increases. The last one, make correction. Okay, until here, is that clear? No need to memorize. We can using formula. For the x, we can using formula to understand how it will changes the x. When we change the A, change the D, change the wavelength, how it affecting our x, we can know from the formula. Then the brightness, we're using the logic thinking to understand it, not memorizing. Okay, any question until here for this part? Okay, okay. Then we try page number 3. No, not try. We come to the page number 3. Okay, combine with what we learned just now, path different. Okay, bright fringes is because a constructive interference or construct. Then dark fringes is because destructive, constructive. Okay. Okay. This one is just telling you that path difference is 0, so it's construct. Point B is half wavelength. Half wavelength. This is what we learned just now lah. Okay. What we learned just now. So it will get a destructive at point B. Destructive. Then point C is 1 wavelength. Half different is n wavelength. So this is a constructive again. So the main thing is here, intensity. At the center here, it will be a higher intensity. Then after that, decreasing. Okay. So at here, the maximum light intensity appears at the center. Okay. Then it will decrease as we move further. Okay, so at here, one more that I want to emphasize is because I saw the past year question talking about sound. Sound. At the end, the answer should not be touching to 0 like the light wave at here. Okay, why? It's because sound wave actually is longitudinal wave. Sound is longitudinal wave. It cannot polarize. Still remember what is polarized? We have the filter. So the wave filter something like this. So the wave will come in. If they are same direction, they will allow to pass through. Okay. So if they are in the wrong direction, for example, they're moving in this direction, then it will be blocked. Okay. Then if like this, then it moving up, down, it can pass through. But for the sound wave, how it move? It longitudinal. It will be moved forward, backward, forward, backward, forward, backward. So no matter what kind of filter you are using, actually sound wave, longitudinal wave cannot polarize. No matter you using like this, they just passing through only what? Because they move forward, backward, forward, backward, forward, backward. Okay, if they cannot be polarized, okay, that means that it won't be blocked. It won't be blocked. When it not be blocked, of course, all the time it will have amplitude. It will not block. Not blocking. Okay. Then amplitude, they will have amplitude. Amplitude won't be 0. Intensity, like what I say, intensity is directly proportional to A. So your intensity also impossible to be 0. So here, got past year question asking, okay, what types, if they're mentioning about wave, here they're never touching to 0. Because for the sound wave, their intensity won't be never touching to 0. Okay? So, but not much question. I saw 1 question or 2 question only regarding the sound wave. Okay, just want to emphasize at here, if the question is talking about the sound wave, it won't touching to 0 lah, that's all. The intensity will not be 0. Okay, until here, is that clear? We try past year question right now. Is it okay? We try past year question right now. Okay. Like dear, actually easy. For those graded from SPM, this one small case for you. Okay, here The pattern using red laser, double slit, and the screen. The screen is 3.5 from the slit. Screen until the slit. So this is D. Light having the wavelength. So label this is wavelength. Okay, this is the pattern of fringe. Okay, bright to another bright. This is not whole X. X is bright to bright. This is called X. Here is called X. Bright to bright fringes. Okay, so here is X. How many X for 72? 1, 2, 3, 4. 4X actually is 72. Okay, so wavelength equals to AX divided by D. Your wavelength is 640 equals to your A. Where is your A? Oh, they're asking you about A, separation of the slit A. What is your X? Calculate. What is your X? What is your D? 3.5. Dear, can you try? What is your X? Then what is your wavelength? Be careful with the wavelength. Why I got so much space at here is because, can you see? This is nano. Nano is times 10 power of negative 9. So this is nano. Washini correct? Nano. So what is your X at here? Should be 72 times 10 power of negative 3 divided by 4, because actually 72 is 4x. Okay, so at here, this one times 10 power of negative 3 is because this is milli, 72 millimeter. Okay, any question? Actually, just apply formula, but you have to be careful with the x, be careful with the prefix. Answer, yes, Wesley, correct. Answer is 1.2 times 10 power of negative 4 meter. Answer is A. Any question? Can we proceed? How about okay? How about others? You think okay? Only two? Okay, Manjo, okay. Manjo, easy, right? You learned this before. Washini, Wesley, okay, dear, here. In the double slit interference experiment, light frequency. Teacher, we don't have using the frequency in our formula, what? Yes, but when they give you the frequency, actually we can calculate wavelength. Using the frequency given, we can calculate wavelength. How? V equals to F lambda. Teacher, it doesn't give us the speed, what? Yes, but look at here, light. What is the speed of light? 3 times 10 power of 8. Then you got the F, you can calculate your wavelength. So first step at here, you should calculate your wavelength. Okay, the bright fringe that are 3.0 mm. So this one is X. Okay, what is the separation of bright fringe? What is your new X? When the frequency change, when your frequency, new frequency, what is your new X? Okay, so at here, how we do it? Wavelength equals to AX divided by D. Okay, so at here, you need to calculate the wavelength, original wavelength, and then the new wavelength. Then AX divided by D. I want to know the new X. AX divided by D. Okay, here you can calculate these by using the frequency. Okay. Then after that, A and D doesn't change. They didn't say that they changed the setup. They just say that I change frequency. That means this one and this one, they are the same. Okay, they are the same. So can you try to find out what is your new X? Or I can say like this. A over D is wavelength original divided by original X. So this one is wavelength new divided by X new equals to A over D. Okay, doesn't change setup. So your A over D is constant. So wavelength O over X equals to new wavelength over X new. Okay, so these two you have to count by yourself. These two count, and then XO is they told you. 3 times 10 power of 3 times 10 power of negative 3. Can you count what is your new x? Like, boys and girls, do your calculation and tell me. Do you able to get my idea, dear? Whole setup doesn't change. What they change is change the frequency. Okay? So change the frequency from the frequency, I can know the wavelength. V equals to F lambda. 3 times 10 power of 8. The starting frequency is 6 times 10 power of 14 wavelength. So your wavelength, original wavelength should be 5 times 10 power of negative 7 m. Okay, then your new wavelength, V equals to F lambda, 3 times 10 power of 8. Frequency, new frequency is 5 times 10 power of 14. So wavelength new. Wavelength new is equals to 6 times 10 power of negative 7 m. Calculate what is your x new. Vashini correct. Fawa correct. How about others? Do you able to get the idea for this question? Whole setup doesn't change. Only change the frequency. Frequency changes, that means wavelength change. Kai Qian correct. Manjo Manjo, I think this one should be no problem for you. In SPM, we're also doing this kind of question. But we didn't using frequency to find wavelength. They are more straightforward, give you the wavelength. Then you have to know they didn't change any setup. So A divided by D is a constant value for the first or second. Wesley, correct. So dear, if you're using the method that I told you, your answer should be donkey. In future, I will upload our Zoom video recording to the YouTube. Only those with the link, then you can get the link and enter the link and study back what we have discussed in our lesson now. Okay, you can revise. Okay. Okay, dear. Done. Can I proceed to the next question? Okay, Manju okay, Fawa okay. Jore, Section okay. Okay, dear, we goes to the next page, huh? Let me have a look. Jore, yes, okay, dear. Okay, number 3. A source of coherent light is incidence on the two slits P and Q that are placed 80 mm. So this is A. Okay, A. The light has a single frequency that gives you frequency. So again, from frequency, we can calculate wavelength by using formula V equals to F lambda. The light from the slit meet on the screen that is 4 meters away from the slit. This is D. The screen is parallel, okay. The intensity sensor, so at here, the sensor at here, exactly at the center, at the midpoint of the interference pattern such that the intensity reading is maximum. Okay, so at here, starting at here is maximum. The intensity sensor is moved along the screen. The sensor travels through two intensity minima, two intensity maxima. Okay, here maxima goes to minima, then goes to maxima, then goes to minima. Not yet enough because one minima, then one maxima, then one more maxima, two minima, two maxima. Where it stop? It stop in the middle of the third minimum. So at here, it stop at somewhere here. Okay, so like this, 1, 2. Pass travel through two intensity minima, two maxima. At the end, stop at the center of the third minima. So at here, from here to here, until here, yeah. Okay, How many x? How many x? So at here, maxima to maxima is called x. Then goes to another maxima is another x. But here goes to minima, that means half x. In total, actually, is 2.5x. Do you agree with what I draw and what I tell you? Can Manjo, okay? We're starting from the center, which is maximum. Then we go to minimum, maximum, minimum, maximum. And then we stop at the third minimum. So from the starting until I stop, I found out that actually we already go through 2.5x. They're asking you how far the distance for this 2.5. Okay, so boys and girls, what is your task? Finding your x. At the end, the sensor distance traveled by the sensor, it will become 2.5x. So calculate out. That is your answer. Do I need to guide you more? I don't think so. Can you try? Find your x first. Wavelength equals to x divided by d. Find your x. Don't have wavelength using the formula v equals to f lambda. Don't have the speed 3 times 10 power of 8 meter per second. Vashini, very good. Yes. Vashini, you may try with the next question. Since you're done, I'm waiting for others. Ashley, no. Manju, no. Manju, no. No, Wesley. Jore, correct. Okay. First step, V equals to F lambda. 3 times 10 power of 8 equals to the frequency is 1.5. 1.5 times 10 power of 12 wavelength. Wavelength should be 2 times 10 power of negative 4 m. Okay. Then after that, substitute second wavelength equals to x over d. Okay, so 2 times 10 power of negative 4 equals to your A. What is your A? 80. So at here, 80 times 10 power of negative 3 times x divided by d. What is your d? D is 4. So x is equals to 0.01 meter. I get 0.01 meter for this step. Taichen, no. Fawao, no. Why you guys get A? Check and then tell me what is the problem. Okay, here, third step, last step, I get the x. So at here, that means that my distance will be 2.5x, which is the 2.5 times 0.01. 2.5 times 0.01. Wait, where's my calculator? 2.5 times 0.01. So it will get 0.025 m meter. So here answer all is mm, so it will become 225 millimeter. Answer should be C. Like those get A, tell me which part is wrong. Fawal correct. Have to multiply? Have to multiply which one, dear Mancho? You means why need to multiply 2.5 or what? I thought D given already. D given, D is here. 4. Wesley, D is given 4. Then find x, then divided by 2.5. Find x, then divided by 2.5. Why need to divided by 2.5? It's times 2.5. The x that you get actually is from here. This is called x. Okay, the x I get 0.01. Another one more x, 0.01. That means 0.02. Then this one, half of it. So at the end, I get 0.025. Wesley, tell me, then why find D again? Not find D, this is distance. Distance, the sensor travel from here until here. This is the distance traveled by the sensor. It travel 2.5x. 25 times 25. Why 25? 2.5, dear. Manjo 2.5 times 0.01. I straight away put 2.5 inside the formula. Oh, cannot. Cannot, dear. Cannot. This formula is talking about x1. Talking about this. We have to find out what is your x. Then only calculate from here to here. Then Wesley ask me question. So I know I need to know which part you confused. Do you able to get the answer? Do you able to get the idea? From here, okay, goes to maxima is called x. You find out x first. Okay, get the idea? Okay. Manjo okay already, So we goes to the question number 4. Next page, Let's go. Monochromatic light is incidence on a pair of narrow slits at a distance. Oh, okay, this one, Read the question. Narrow slit. Okay, narrow slit. So this is A. A series of bright and dark fringes are observed on a screen distance. So this is D. The distance between the adjacent bright fringes, this is X. Bright to bright is X. Okay, so what is the path difference? Wow, they're asking you path difference. Okay, so wavelength equals to X over T. Path difference is involved with in terms of wavelength. Am I right? Still remember path difference? Path difference just now that we learned. It can be n wavelength or n plus half wavelength. Okay, involved with wavelength. So what you need to do for this question is find out your wavelength first. Can you find out your wavelength first? Find out your wavelength. What is the path difference between the light wave from the two slits that meet at the second order dark fringe? Dark fringe, highlight dark fringe. Dark fringe actually is constructive or destructive? My answer is destructive. That's why dark. Destructive. Okay, then monochromatic, that means that they come out with the coherent. Coherent, that means they will be here is in phase. Okay, they didn't mention about out of phase, so it's by logic is in phase. So if in phase destructive, it should be this formula. So this is what we learned just now. Is it okay? Calculate your wavelength first. Then second order of dark fringe. Okay, second order. If second order, you look at here, this is 0, n equals to 0. Second order, so this one is n equals to 1. Second order for dark fringe actually is n equals to 1.5. So that means that this one, it should be 1.5 wavelength. Then path difference, what is their path difference? Why in phase? Why in phase? Okay. Monochromatic light, that means that the wave with a single frequency, single wavelength. Then at here, some more they didn't mentioning that the light coming out actually is the out of phase. So at here, when the light wave coming, they go out, actually they will be in phase. They will be in phase. Monochromatic light come here. So here they will be in phase going up. Because these two wave producing from the same source at here come out here. So they will be in phase. So in phase, for the destructive interference, we know that got 0.51, 0.5. So at here, center here, we say 0, n equals to 0. Then the next bright fringes, we call it as n equals to 1. Dark fringes, it will be 1.5. Answer C, correct. Answer will be C, correct. So if you do it correctly, your wavelength should be 4 times 10 power of negative 7 m. So 4.4 times 10 power of negative 7 times 1.5, you get 6 times 10 power of negative 7 m. Okay, here there is another new idea for you. Here, center is n equals to 0. Then n equals to 0 goes to the next bright fringe. It will be n equals to 1. Then goes to another bright fringe, n equals to 2. Then the dark fringe at here, it should be n equals to 1.5. It's not 2.5, dear. Don't confuse by the second order. Washini correct. Okay, dear, if correct, then we go to your next page. Can we go to your page number 7? Okay, Kai Chen okay. Wawa okay, Manjo okay. Fatima okay. Okay, let's go, dear. Okay, this one, they got a red light. They got the violet light. So wavelength for red is actually longer than wavelength for violet. They assume we know about this knowledge. Okay, when we learn about electromagnetic wave, we know about this. Okay, the wavelength of R is approximately twice the wavelength of V. Parallel going, white screen showing. What is the pattern? Okay, first, dear, look at here. This is the pattern. Can you see that intensity at the center will be the highest, then it will decrease. Okay, so at the center will be highest. So first step, here A here slightly wrong. Okay, so this part, it should not be a 0. At the center, it should not be 0. So we look at the B, C, D. So at here, ask yourself, wavelength equals to AX over D. Wavelength higher, then what happened to your X? It should be higher also, right? So at here, your X for red color, it should be greater than your X of violet. So you look at B, C, D. Which one you think is correct? Red to red. Okay, what is your correct answer? Wesley correct. Fatima correct. How about others? Do you able to get the idea? You see? Red color, red color, the X actually will be a longer X. Longer X. So, from here to next maxima for X, for red color, it should be a longer. Yes, Kai Qian, correct. Answer should be C, dear. Answer should be C. Because wavelength for red color is longer, so the X should be higher also. So at here, can you see that this one is red color? Red until the next red. Okay, then violet. Violet is from here going to here. Violet with shorter X. Is that clear? Is it okay, dear? Okay, then we goes to the next page. Okay. Why there is a bright and dark fringe is formed on the screen. Okay. First, when they pass through the gap, I know we got two gap. When they pass through the gap, they will spread out. We call it as diffract. Okay, diffract. Then we got two wave. Okay, because we got two hole at here, so they will superpose, or we say they meet up. Okay, so bright fringes is formed is when constructive interference, okay, is happen. So constructive is meaning that they are in phase, their phase difference is zero. So when I'm crest, you also crest. When I'm trough, you also trough. We don't have different. Okay, so phase difference is zero, constructive interference happen, a bright fringe is formed. When phase difference is 180 degree, meaning that when I'm crest, you are trough. So when we meet up, okay, we producing the destructive interference. So that fringe is formed. Is that clear? Okay, this one actually is not that difficult. I don't want to spend time at here, but the things is this one is how many x are? 1, bright, 2, bright, 1, 2, 3, 4, 5, 6. This one is 6x. Then you just apply formula only. You write down the final answer, 6.6 times 10 power of negative 7 m. Okay, the rest actually is nothing tough lah, nothing challenging. Oh, repeat. Which one? Repeat this one. Okay, dear. Wesley asked to repeat. Bright and dark fringe. How it form? Why we got teacher? Why we got bright? Then dark, bright like this. Okay. First, the light coming at here. When they passing through the hole, the wave will spread out. This is called diffraction. Okay, diffraction. So last lesson we learned diffraction, spreading out of the wave. So first they diffract. Then we got two hole, right? Two gap. So two hole, we were producing two wave like this. These two wave, they will be superposed. Okay, they will superpose and they will be meet at the screen at here. Okay, so at the end, we will get a bright fringes, dark fringes, bright fringes, dark fringes. Is because bright fringes is due to the constructive interference. Constructive meanings that crest meet with crest, so we get a bigger crest. Trough meet with trough, I get a bigger trough. Okay, constructive. How we crest meet with crest? When the two wave, their phase difference is zero. Okay, no phase difference meanings that I'm crest, you also crest. No phase difference. So bright fringe is formed. Okay, when the phase difference is 180 degree, meaning that we producing the dark fringe. A crest meet up with a trough, so we get a zero. So this is called destructive. Destructive, you see, this one is crest, this is trough. Their phase difference actually is 180 degree. They're producing destructive interference. So Wesley, is it okay? Yeah, okay, dear. So here, this one is just do substitution only. You write down final answer. Okay, now the light is replaced by another different visible light with a shorter wavelength. Okay, x equals to wavelength equals to x over d. How the new fringe separation? What is your new x? Okay, I rearrange wavelength d over a. So now they say that shorter wavelength. So this one shorter wavelength. What happened to your x? I told you no need to memorize. We're using formula to answer the question. Yes, Kai Chen correct. Washini correct. Fawa correct. So what happened? Okay, smaller, decreases, shorter. All are correct. Using formula helping us. Okay. Then next, can we proceed to the next page, page 7? Yes, Wesley. Okay, how about others? Our okay. Machine okay. Okay, like dear. Okay, next one at here. This is your A, this is your D, this is your X. Nothing to trick you. But just don't forget about the M. The here have to convert to meter, only do substitution. Okay, so this one I also not going to talk. So at here, can you write it down? The final answer should be 5.8 times 10 power of negative 7 M. Because nothing difficult, just do substitution only. Okay, the main thing that I want to discuss is at here, D. The width. So at here, this one, the width for each slit is decreased. There is no change to the separation of slit. So no change of separation of slit. That means that A is unchanged. A unchanged. Okay, A is unchanged. So they didn't change other setup. They didn't change the light frequency wavelength. They didn't change the D. All are unchanged. So from the formula, X wavelength equals to AX over D. Unchanged, unchanged, unchanged. So what happened to your X? Also unchanged. Then what is the difference? Okay, here the difference is, okay, we look at this theory part. Here, you see this one, I increase the gap size. Okay, gap size, but my A is still the same. It doesn't change for our X. It's because in our formula it doesn't changes. But here, if we increasing the slit, we are increase the brightness because this gap is bigger. I allow more light to pass through, go through. Okay, if I using a smaller width, then my brightness will decrease. Okay, so at here, look at the answer. Okay, you see, if the what decrease the width, okay, here decrease the width. If you decrease the width, so here can you see that small gap only? Okay, the gap is small, you will diffract, more diffraction happen. More diffraction happen is because of your narrow slit. So this is the previous lesson we learned. I told you your table and your very best friend table very close. Until your teacher want to pass through, we cannot just go through like this. We have to turn our body and go pass through by our side. Okay, so at here, when the gap is too small, it will diffraction effect will be more obvious. Okay, the wave will be spread out more. Then at here, what else? The bright fringe will be less bright is because the gap size is small. The width is small, less light can be passed through. Okay, no change to the X. No change to the X. Is that clear? Is that clear for this? Wesley okay, Manjo okay, Prasan okay, Vashini okay. Okay, so we goes to the next. Okay, here, let me have a look. Oh, coherence. Okay, dear, you see page number 11 also asking you coherent. Okay, also asking you coherent, constant phase difference. So this question, page number 10, also asking you what is the meaning of coherent. That means that this definition you have to memorize. It's very important. Okay, you complete by yourself. Okay, here. This is our A. This is our D. Okay, what else? Wavelength. So label, this is wavelength. Then after that, what else? Let me have a look. The center bright fringe is formed at point O. So this is center. Then we got the dark fringe, bright fringe, dark fringe. Okay. So what is the question? When the two waves superpose at R. So first, we come back to R. R is what? R is dark fringe. Dark fringe is what? Dark fringe is destructive interference. Write down. Okay, this is destructive interference. So destructive interference will form dark fringe. Okay. Then the question asking you difference in their path length. That means path different. They want to know path difference between the two light. Okay. So the two light from here, it will comes to here. Okay. Then another one will become from here. They want to know their path difference. Okay, how I know? Okay, center here is n equals to 0. Bright fringe n equals to 1. Dark fringe is n equals to 1.5. Is that clear? Dark fringe is 1.5. Center bright fringe is 0, then goes to another bright fringe is 1, then not yet goes to another bright fringe, it's only half, goes to the dark fringe is 1.5. So at here, the path difference is actually 1.5 wavelength. Okay, then you do calculation for the wavelength. Here, wavelength is 660. Okay, here is nanometer, so we no need to change. 660, we really use. My answer is 990 nanometer. Okay, until here, any question? R is destructive. Power, okay. How about others? Okay, you think good job. Okay, phase different. Path and phase different is different. Phase different is in degree. Phase different, as I told you, path different in terms of wavelength, divided by wavelength times 360 degree. Okay, what is the path difference at point R? 1.5 wavelength. 1.5 wavelength. So divided by wavelength times 360 degree. So the answer will be 540 degree. So today we combine path difference with the phase difference that we learned previously. Is that clear? Fatima, okay. Vashini, okay. Manjo, okay. Okay, boys and girls, we go to your next page. Goes to the next page, Okay, here, let me have a look. Coherent. So this is important, Okay, next calculation to your A. Okay, from here, they want to know what is your A. Wavelength is this. D is this. What else they give you? Let me have a look. Oh, X. Okay, because wavelength equals to AX over D. I want to find X. I have wavelength. I have... Oh no, we want to find A. Okay, we want to find A. So we have the D. How I know the X? From here to here. But this is not your X, boys and girls. This is not your X. So from bright to bright, this is called X. So I got 1, 2, 3, 4, 5, 6, 7, 8. I got total 8 X equals to 22 mm. So what is your X from here to count? Okay, but this is not a challenging question. So until here, is that clear? All the value you have, you write down the final answer, 6.3 times 10 power of negative 4 meter. Okay, just substitution only. The not challenging is this part only. Okay, not really challenging. We have to know, this is basic knowledge. We have to know this is X. So you write down the final answer. The main thing is actually I want to discuss about this. Okay, the path different and phase different. You see these two questions, they are quite similar. The way they're asking is quite similar. Ask you path different, then ask you phase different. Okay, fringe P is the center. Okay, Q and R is the nearest dark and bright fringes. Then calculate the distance different in the distance path different. Okay, from the to the center of fringe Q. Okay, here. So this is center. They told you, not I told you. It's the question told you. Fringe P is the center. Okay, so this one is at the center. That means that here P, this point, n equals to 0. So goes to another bright. This is n equals to 1. The question asking you goes to the center of Q here. So what is your Q here? N equals to 0.5. Dark fringe, n equals to 0.5. Can you see that? Here, center is 0. Then goes to another bright fringes is 1. In between here, dark fringes actually is 0.5. Okay? So at here, path difference. Question asking you, what is the path difference? Path difference. So we write down path difference is equals to, just now is 0.5 wavelength. Okay, so at here 0.5 times the wavelength they given in the question is 6.2 times 10 power of negative 7. Is that clear? Wesley, okay. How about others? Okay, 3.1 times 10 power of negative 7 m. Okay, so phase different. Okay, I don't want to talk anymore. Phase different. Can you count and then tell me what is the phase difference? Refer to just now previous question. The way they ask is quite similar. No, dear. Fawal, no. Hey, wait, let me have a look. Fawal, read the question. I know your problem. Fringe out. Not talking about fringe Q. I know your problem, Fawal. Fawal correct. Vashini correct. Good job. Kai Chen, good job. Where is Tony? Today I saw Tony online. What? Okay, dear. At fringe out, fringe out. Out at here is n equals to 1 wavelength. Okay, so at here, 1 wavelength phase difference equals to the path difference at r, path difference at r, divided by wavelength times 360 degree. So just now the r, we found out that is 1 wavelength. N equals to 1 wavelength. So divided by wavelength times 360 degree. So path difference is 360 degree. Yes, Manjo, correct. Manjo, I think it's because you're still using Q, is it? Fringe Q, right? Yes. So read the question. Okay, dear. Until here, this is lesson 37. We are going to lesson 38. Any of you got any question want to ask me? Get the idea? Okay, can we proceed? Yes, Wesley, okay. Washini, okay. How about others? Where are you? Kai Chen, okay. Yes, Manjo. Manjo want to say something? Yeah, Manjo, faster. In phase, then destructive interference? No, it's construct what, dear? See? Manjo asking question, for the R at here, see, this is bright fringes, then goes to bright fringes. R is bright fringes. It's a whole number. Can you see that? It's a whole number. For Q, if for Q, that is destructive. Yes, you see 0.5. It's 0.5, got 0.5 wavelength. That is a destructive. Okay, like this, we go to the next lesson, 38. Diffraction grating. When we saw diffraction, it's only talking about one gap. Wave coming and then spread out, am I right? But if let's say the whole one gap, we make it many gaps. See, many gaps. Okay, so this is called diffraction grating. Consists of large number of very thin, equally spaced parallel slit. Okay, so at here, the pattern that we will get will be here like this. Okay, let me have a look. This one, yeah. something like this. Okay, so we can, it doesn't allow me, wait, let me have a look. Okay, this one, when we change the number of the line, grating line per mm, so this is the point that we will find out the pattern now. Okay, so when we change the wavelength, we're also changing the pattern. Changing what else? Changing the distance. Okay, there is few factor affecting now. Okay, so at here, come back to here. This is the pattern that we can observe from the screen. So the pattern will be changes when we change some factor, okay, variable. So at here, diffracting, grating come in different size. The size depends on number of lines per millimeter, okay? So this one, actually what they're giving to you is called N. This is called N. This is called N. Okay, meaning that 1 mm, 100 lines. Okay, when N showing you 100 lines per mm, meaning that per mm, every 1 mm actually is 100 lines. Okay, until here, is that clear? I want to go to the next page. Okay, Vashini, okay, dear. Next. So this is the pattern that I show you just now from the simulation. On the screen, we will find the pattern, dot, 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 okay? So it will be using this formula, okay? We can using this formula to find out that how many dots that we can observe from the screen. Okay, from the center here is 0. N equals to 0. Then another point that we can observe, N equals to 1. Another point, N equals to 2. Then going down also the same, N equals to 1, N equals to 2. Okay, so we having this formula, D sine data equals to N wavelength. Okay, here D, what is D? D is the spacings between the slit. Okay, spacing between the slit. How we do calculation for D? You from the N. Just now I told you what? The N is 100 lines per mm. That means that every 1 mm you got 100 lines. Now my question is 1 lines. Okay, 1 gap. How many? What is the D? Okay, what is the D? So from here, how we do calculation using your mathematics, it should be 1 over 100. Correct or not? 1 over 100. So actually it's 1 over n. 1 over n. So how we calculate the distance between the slit, okay, between the hole, very, very small hole, you're using 1 over the n. But of course, here is mm, here is mm. So at the end, at here, we will need to convert it to become m, not mm. Before we use in the formula, we have to make it in m. Okay, so next, D, we know already, calculate by using 1 over n. Sine data, data is angle, is from the center, n equals to 0 here to measure it. So when first order, then this is the angle. When we measuring for the second order, from 0 here until the second here, n equals to 2. Okay, so n is the order of maxima. We call fringe as maxima. Until here, any question? Here later on we do some calculation, then I will explain more lah. Okay, I will explain more how we convert to meter. Okay, so you got the idea. D is actually, if they didn't give you directly, we have to calculate from 1 over n. Then the angle is from the center go up until your order. N equals to 1, n equals to 2, depends. Okay, wavelength will be given. Okay, here, what is the maximum angle of diffraction that can be seen? Okay, so at here, this is from 0. We are starting from n equals to 0 center here. We're going up this angle until the maximum at here. Our maximum angle actually is 90 degree. Right angle, 90 degree. Okay, so this is the maximum that we can see. Okay, when delta is 90 degree, sine delta, sine 90 degree, actually we get 1. So at the end, the formula, it will become D equals to N wavelength. For me, actually, we remember this. Then when they say maximum point that you can see, maximum the number of order that we can have, then we just put one for this one. That's all. No need to memorize so many formula. Okay, so at here, I repeat, n sine the not n, d sine delta equals to n wavelength. This one, because sine 90 degree is equals to 1, so it becomes dn wavelength. How many highest order maxima we can calculate? N is number of maxima, order of maxima. So it will become d over wavelength. No need to memorize. We're still using the basic formula we can solve. Just telling you, okay? So n is an integer number of maxima. If let's say you're getting the value is 2.7, dear, you need to going down, round down to become n equals to 2. Okay, that means that if n equals to 2, that means that here is n equals to 1, n equals to 2. It goes to another one, actually it's 2.7, but because it's already out of our range, so we only can say 2. 1, n equals to 1, n equals to 2. This is the maximum number of order of maxima that we can have. Until here, we are going to practice our past year question. Any question you want to ask me? Or maybe we go to the past year, then we can understand more. We go to the past year, we go to the past year. Okay, this one, I don't want to talk first. Okay, we go to past year first. Okay, this one. What is the wavelength? Okay, diffraction grating. So the formula that we need to use is d sine delta equals to n wavelength. D at here is the distance. So this one is already giving in distance, spacing of the slit. So they already give you D. We just use only times 10 power of negative 6 sine. Okay, here they say that angle between the first order. That means that this is n equals to 1, n equals to 1. Center is n equals to 0. 1 to 1 is 60. But what is the angle I should use? Always remember we are from the n equals to 0 until n equals to 1. So I need to using 30 degree instead of I using 60 degree. Is that clear? Okay, here they say that first order. So this one n equals to 1. So n is 1 wavelength. From here we can calculate the wavelength. Okay, from this past year question, do you able to get the idea? How to use this formula? Wesley, okay. How about others? Farwell. Oh, Farwell, where are you? Hey Qian, yes, correct. Right, boys and girls, answer will be C. Okay, I want to go to the next question. Is it okay? Okay, next. Okay, this one, the wavelength 567. Grating have 400 lines per mm. Dear, this one, what they're giving you is n. N is 400 lines per mm. Okay, a number of diffraction maxima is observed. Okay, then what is the angle between second and third? Angle for the second order and the third order. Angle between them. Okay, so that means that we need to using the formula d sine theta equals to n wavelength. The d we don't have. We have to calculate d first. D is 1 over n, and I told you we need to convert to meter, not mm. So that means that 1 divided by 400 lines per mm. M is 1 times 10 power of negative 3. In mathematics, I can write 1 divided by 400, then divided by 1 times 10 power of negative 3. 1 divided by this. Per mm, per, that means that divide, per meaning divide. 400 divided by mm. M is 1 times 10 power of negative 3. Okay, so 1 times 10 power of negative 3 over 400. So basically, how we calculate D is 1 over 400, then times 10 power of negative 3. This is because I convert from mm to m. In future, I won't talking in so detail. So in future, I will straightly just convert and make the mm at the top. Okay, until here, do you able to get the idea of the mathematic? This is mathematic. Machine, okay? Okay, sine delta, this is delta 2 equals to the n is 2 because now I'm talking about second order. Okay, then wavelength. What is the wavelength? 567. 567 times 10 power of negative 3. Sine delta 2, what is this? Then again, 1 times 10 power of negative 3 over 400 sine delta 3. The order is third, then 567 times 10 power of negative 3. What is your delta 3? So this is third order. Okay, can you calculate and then tell me? Manjo, correct. Teacher must be 5, 6. Oh, sorry. Yes, dear. Thank you. Sorry. 567 times 10 power of negative 9. Yes, thank you, dear. Oh, negative 9. Nano. Negative 9. Thank you. Rashini, thank you. Jore, correct. Okay. What is the angle between second order and third order? So this one, you have to find delta 3 minus delta 2. Answer should be C. Is that clear? Kai-Chen, no. Kai-Chen, check which part. Which part are you different with us? My angle for delta 2 is 27 degree. Delta 3, I get 42.9 degree. Kai-Chen, you check which part is different with me. Kai-Chen, you get the idea? Kai-Chen, okay already, huh? Okay, dear, here. They give you the wavelength 400 nanometer. And they give you n 300 lines per millimeter. The light pass through the grating and produce a series of maxima which are observed on a semicircular screen. So that means that at here, the maximum that we can saw the angle is 90 degree lah. They're asking you total number of maxima n that we can observe on the screen. So this one is n equals to 0. So we will continue have n equals to 1 until n equals to something, something like here. Okay. So at here, what should we do? Do calculation. And d sine delta equals to n wavelength. Can you calculate the n for me? No angle, teacher. No angle also never mind what. This one, the angle will be sine 90 degree. Now, try to do calculation for D. Remember how to convert? 1 over 300 millimeter. Then you make the timestamp power of negative 3 at top. Then you got the D. Wavelength you got. Can you calculate your N? Manjo, you get halfway. Halfway. Not the final answer. Why? Total number of maxima observed on the semicircular screen. Semicircular screen. What you count actually is where only one side. Then total still not reach to the answer. Okay, wait, this one is 1 times 10 power of negative 3 divided by 300 equals to the n we don't know, 400 times 10 power of negative 9. So n at here you will get 8, am I right? But 8 is not your final answer. Washini correct. Fawal no. Why no, you know? Dear, until here, you will get n equals to 8, am I right? 1, 2, 3, 4, 5, 6, 7, 8. Then how about the bottom part at here? You also get n equals to 8, 8 what? So you got 1, 2, 3, 4, 5, 6, 7, 8. Then this is 0. 1, 2, 3, 4, 5, 6, 7, 8. In total, how many dot you can see? Okay, the total number of maxima, it should be, okay, you got 8 up and down. So up and down, and then also one more. Why one more? N equals to 0, also a dot. So answer should be 17D. Wesley, correct. So those choose 16, actually you haven't considered the center dot. Center also got a dot, what? Wanjo. Right, dear? Cannot, Wesley. The way that you do, cannot. You have to make 8.33, go down, round down, become 8. Then only 8 times 2 plus 1. You cannot using the method that you mentioned just now. Okay, dear, no question. Can we proceed? I want to talk 2 more questions. We delay a bit today. Okay, here. Let's go here. This question actually is same thing. They just reverse just now the process. They tell you total got 9 dots. Total got 9 dots showing on the screen. Can you tell me what is my maximum number, order of number? Total, what is my n? What is my n? That I can get maximum n that I can get. Any of you can tell me? Total, I got 9 dots. What is my n? Kai Chen, good job. Yes. Wesley, oh, your n got 19. How you get 19? The total dot that we get is 9 what? 1, 2, 3, 4. 1, 2, 3, 4. Total 9 dot on the screen. Manjo, yes. Manjo, yes. Fawal, no. 9 dots. They got 9 dots. And at the center at here, this is n equals to 0. N equals to 1. N equals to 2. N equals to 3. N equals to 4. Going down also the same. It will be n equals to 1. N equals to 2. N equals to 3. N equals to 4. Total at here, we got 9 dots. What is your n? N is 4. My Fawal, do you get the idea? Now they reverse just now the question. Just now is we calculate our n, we get 8. Then they asking you what is your total that we can get from the screen. From the upper part, I get 8. From the bottom part, I get 8. So I need to care about the center here. N equals to 0. So in total, I got 17. But what is my n? My n is 8. Why is 8? 17, I need to minus 1 first. Then divided by 2. 17, I need to minus the center. N equals to 0. I ignore this first. Okay, so at the end, I get 16 divided by 2. Then my n, actually, n is equals to 8. So actually, this question is reverse just now the question. Okay, so for this question, you do it by yourself. The harder part, I already told you. You write your final answer A at here. Okay, I already told you your n is 4. The rest is just do substitution only. Yes, Wesley, correct. Okay, boys and girls, is that clear? I want to go one more question. Okay, one more question at here is talking about red light. Starting this one is red light, red light. Then bright dot will be formed on the screen. The red light is replaced by a white light. So that means that we got not only red, we got the 7 color. Okay, which diagram draw to the same scale show the possible pattern of the bright light on the screen. Okay, so I can go back to here. Here, white light. If let's say we are white light, at the center at here is still getting a white color. Okay, why? All color are in phase, so they will join back. So center here is white light. But when we go to the either side at here, it will different story. Why different story? Okay, you will find out that the purple color, the violet, okay, closer to the center. Then the red color actually is largest angle here. So near to the center is purple, then after that red is further away. Why like this? It's because red color have a longer wavelength. They assume we know 700 nanometer. This is red color wavelength. Okay, wavelength higher, so your angle also greater. That's why red color will be deflected to a greater angle. Okay, for this theory, is that clear? Red color will be further away from center. Is that clear? Yes or no? Kai Chen, okay? Manju, okay? Okay, then we can come back to this question and answer the question here. Okay, when white light. So at the center, all will be focus and still white light. Okay, at the center, still white light. Okay, then after that, from the center, they will spread out because got 7 color. Then which one is the correct? So you look at this. This is a red color. When it's spreading out. Red color when it's spreading out. Red color when it's spreading out. Red color when it's spreading out. Can you see that the red color will be further away from the center? That means that this one should be the violet. Here should be the violet. My answer for this question is donkey. My answer for this question should be donkey. Red color, wavelength for red color is actually longer wavelength, so the angle will be a greater angle. Greater angle actually is further away from center. So it should be donkey. Red color still maintain. This is red color. I know that starting this is red color. So when I draw it down, this red color is further away. So this is a correct pattern. Is that clear? Okay, How about others? Kaichen okay, Vashini okay, Wesley okay, Fatima okay.